NeuroStack is an AWS CloudFormation-based tool designed to aid neuroimaging researchers working with AWS cloud computing. It is ideal for neuroimaging researchers transitioning their workflows to AWS or anyone working with neuroimaging at scale. By installing NeuroStack into your AWS account, you construct a pipeline of AWS resources specialized for neuroimaging. NeuroStack is built with the Nitric Computational Environment, or Nitric CE, allowing users access to all of the programs pre-installed in the Nitric CE. In this tutorial, we'll go over how to install NeuroStack into your AWS account, and 2 examples of using NeuroStack, using 2 different software packages, Afni and FreeSurfer. To begin using NeuroStack, first sign in to your AWS account. Navigate to the NeuroStack page on the Nitric website, and go to Downloads. The download is a URL that will bring you to the AWS CloudFormation Stack page. Once on the stack creation page, everything you need is already preset. Just continue choosing Next. On the final page, check the box to accept that CloudFormation will create IAM resources before creating the stack. NeuroStack will take several minutes to set up your AWS resources. When it says Create Complete, it's finished. Let's run a simple job through NeuroStack to see how it works. We're going to convert an MRI file from one file type to another. We're going to use an Afni program to convert from a NIfTY file type to an Afni file type. The job should only take a few minutes to run so you can see the process from beginning to end. I've downloaded the template script and a test imaging file from the NeuroStack GitHub repo. I'll navigate to the AWS S3 console where I can see that NeuroStack has configured 3 S3 storage buckets, an input, output, and script bucket. I'll upload the script to the NeuroStack script S3 bucket. Let's take a look at the script. The top section contains commands that aren't intended to be altered by the user. The bottom section is meant to be modified by the user. There are 3 basic parts to the section: copying data from our input S3 bucket, performing an operation on the data, in this case using an Afni command to convert file types, and copying our process data to our output S3 bucket. An Afni file consists of 2 files, a .brick and a .head, so we're actually copying 2 files here. The variable asub is defined as the file name before the first period. So in this example, we have a test file called test.nii, which means that asub will take the value test. I'll upload the test imaging file to the NeuroStack input bucket. When I upload a file into the input bucket, it will immediately begin processing the file according to my script in the script bucket. It will take several minutes for the job to complete. When it has finished successfully, we will see our process data in the NeuroStack output S3 bucket. In the meantime, let's watch our job status. We can do that by navigating to the AWS batch console. The job will move from submitted to running. When it has finished running, it will either move to succeeded or failed. Great, we can see that our job succeeded. We can see more details about our job by clicking on it, and we can see that the job's total running time was 12 seconds, which is the computation time that we're charged for. We can also look at the log of our job under log stream name. And when we navigate to our output S3 bucket, we can see that our 2 processed files are there. In this example, we've uploaded a single subjects file, but we can upload multiple files at a time for simultaneous processing by uploading the files either manually or through the AWS CLI. If you have many files to process, the CLI will be more efficient. Let's use NeuroStack to process the subject through FreeSurfer. To do this, we'll need to change our script. In the User Modified section, I have the FreeSurfer setup commands. I copy the data from our input S3 bucket. FreeSurfer requires the license file to run, so I'll copy my license file as well. I'll then do recon all, the command to process through FreeSurfer. And once that process is done, I'll copy my output files to my output S3 storage. Now that we've modified our script, we can upload our script and the FreeSurfer license file to the script bucket and our test data to our input bucket. Again, by uploading to our input bucket, we've started our process running. FreeSifter will take several hours to run. It's the next day, and I can see our FreeSifter output in the Output S3 bucket. I can go to the batch dashboard and see that FreeSifter took 6 hours to run. We hope you will find NeuroStack useful for your neuroimaging work on AWS. If you have questions about how to use NeuroStack, please visit the NeuroStack forum on the NTRIC website. Thank you.